In this video, we want to show that d of xy is a metric on R. So first, let's show that it's greater than or equal to 0. Well, we know the absolute value of x of t minus y of t is greater than or equal to 0 by definition of absolute value. So that means when we're integrating over a non-negative region, it's always going to be non-negative, or in other words, greater than or equal to 0. It's equal to 0 only when x of t is equal to y of t. Because if the integral of a non-negative region is 0, that means the region itself has to be 0. In other words, the absolute value of x of t minus y of t is 0, which means x of t is equal to y of t. The next step is to show it's symmetric. So if I take the integral from a to b, absolute value of x of t minus y of t, that's the same thing as the integral from a to b, absolute value of y of t minus x of t. Because the absolute value of y of t minus x of t, I can factor out a negative 1 and have negative y of t plus x of t. And this negative 1 can come outside as the absolute value, and then I'm just going to rearrange x of t and y of t. And then the absolute value of negative 1 is just 1. So that's just absolute value of x of t minus y of t. So those are equivalent, and so d of x comma y is the same thing as d of y comma x. So next step is to show the transitive property. So we have absolute value of x of t minus y of t, and we're just going to subtract z of t and add z of t. So by the triangle inequality, we know that this is less than or equal to the integral of x of t minus z of t plus integral of z of t minus y of t. So we started off with d of x comma y. So this is d x comma y, and we said it's less than or equal to. This first thing is d of x comma z, and then the second one is d of z comma y. Okay, and so that proves it.